Welcome to the deep dive. Today, we're going to tackle something really important if you're aiming for those senior engineering roles.
Yeah, especially for the technical interviews.
Exactly. We're talking about partitioned databases and specifically how they handle secondary indexes.
It's a classic system design topic. You've probably worked with partition systems, but knowing the details of indexing across partitions, that's key.
Right. We want to dig into the two main ways this is usually done: document-based partitioning and term-based partitioning for these indexes.
Understanding the trade-offs between these two, well, it's fundamental for designing systems that actually scale and perform well.
And it's definitely the kind of stuff that interviewers probe for when assessing architectural thinking.
Absolutely. It shows you understand the consequences of design choices, not just the definitions.
Okay, so let's start with the first one. Document-based partitioning. How does that work?
Okay, so imagine our used car website example again. Loads of listings, each with a unique ID.
Right.
With document partitioning, you split the data based on that primary key, the document ID. So maybe IDs 0 to 499 land in partition 0, 500 to 999 in partition 1, and so on.
Standard primary key partitioning. Got it.
But the key part here is the secondary indexes say for color or make. In this model, each partition manages its own secondary indexes completely independently.
So partition 0 only indexes the cars physically stored in partition 0.
Exactly. The indexes are local to the partition. They only know about the data within their own boundary.
Okay. So if we look inside partition 0, what would we see? We had like a red Honda ID 191, a black Dodge ID 214, a red Ford ID 306.
Right. So partition 0 has its primary index mapping those IDs to the car data. Then it has its local secondary indexes. The color index there would show black, pointing only to ID 214.
And red?
Red would point to IDs 191 and 306, and maybe yellow would be empty in that partition.
Okay. And the make index would be similar. Dodge to 214, Ford to 306, Honda to 191, all local to partition 0.
Precisely. And then partition 1, holding different cars like a silver Ford, ID 515, red Volvo 768, silver Audi 893. It would have its own completely separate set of secondary indexes.
So its color index might show red pointing only to 768 and silver to 515 and 893.
Correct. And its make index would point Audi to 893, Ford to 515, Volvo to 768. Each partition is like its own mini database in terms of indexing.
What's the advantage here? Seems pretty straightforward.
The big win is on the right side. If you add a new car or update one, you figure out which partition its ID belongs to, and you do all the work updating the main data and all relevant secondary indexes right there in that single partition.
So rights are nice and contained. No need to coordinate across multiple machines for a single document update.
Exactly. It simplifies the write path significantly.
There's always a but, isn't there? What about reading? Say I want to find all the red cars on the site.
Yeah, that's the trade-off. Since red cars could be in any partition like our red Honda in P0 and the red Volvo in P1,
Yeah.
you can't just go to one place.
Have to. Ask everyone.
Pretty much. The query coordinator has to send the request, find index entries for color.red to every single partition.
Okay.
Then each partition looks in its local index. Partition 0 finds IDs 191 and 306. Partition 1 finds ID 768.
And then you have to combine those results.
Right. The coordinator gathers all the replies 191, 306, 768, and puts them together for the final answer. This is that scatter-gather pattern.
Scatter-gather. I can see how that might get slow if you have, like, tons of partitions.
Definitely. Imagine hundreds, even thousands of partitions. Querying all of them introduces latency. Even if they run in parallel, your total time is limited by the slowest one to respond.
That's that tail latency amplification problem, right? Where just a few slow nodes can really drag down the overall performance.
Exactly. So for applications needing really fast, predictable reads on secondary indexes, this scatter-gather can be a real headache.
Makes sense. So simple writes, but potentially slow, unpredictable reads. Good to know which systems use this. You mentioned MongoDB, React, Cassandra.
Yeah, Elasticsearch, SolCloud, VoltDB2, they all primarily use this document partitioned approach for their secondary indexes.
Although I guess you can sometimes design your keys to try and minimize how often you need those cross-partition queries.
You can try, absolutely. Smart partitioning key design helps. But for complex queries hitting multiple secondary fields, it often becomes unavoidable.
Okay, so that's document partitioning. Let's switch gears then. What's the alternative? Term-based partitioning.
Right. Term-based takes a different philosophy. Instead of local indexes, the idea is to create a global index, an index that spans all the data partitions.
A single massive index for everything. Wouldn't that be a bottleneck?
Well, Yes, a single centralized index wouldn't work. So the global index itself is also partitioned.
Ah, okay, so you partition the index too.
Exactly. But here's the crucial difference. The index might be partitioned based on the term you're indexing, not necessarily the primary key of the document.
Based on the term, how does that work? Like, back to the cars.
Okay, so for the color index, instead of each partition indexing its local cars, you might decide that, say, all entries for colors starting A through 8 go into index partition 0, and S through Z go into index partition 1.
Regardless of where the actual car data lives.
Precisely. So the entry for color.red would live in index partition 0, and critically, it would contain the IDs of all red cars 191, 306 from data partition 0, and 768 from data partition 1.
Whoa, okay, so the index entry for red aggregates IDs from across the primary data partitions.
Yes. And similarly for make.
Hmm.
Maybe makes starting before H go to index partition 0, and F or later go to index partition 1.
So make Ford might be an index partition 0.
And it would point to both ID 306 from data partition 0 and ID 515 from data partition 1.
And make.Audi, ID 893, could also be an index partition 0, even though the Audi data is in primary partition 1.
You got it. The index partitioning strategy is based on the index value itself.
And looking at index partition 1 in that scheme, we'd find color.silver pointing to 515 and 893, and maybe make, Honda pointing to 191, make, Volvo to 768.
Exactly. The index entries are grouped by the term value.
Okay, I can immediately see the read advantage now. If I want all red cars.
You just figure out which index partition handles the term color.red. In our example, that's index partition 0. You query only that one index partition.
And it gives you the complete list of IDs, 191, 306, 768, no scatter-gather across all the data partitions.
Right. For reads targeting that index term, it's much more efficient. You go straight to the relevant index partition.
That sounds way better for reads. So,
yeah.
What's the catch this time? Must be the writes.
Bingo. Writes get more complicated. Think about adding that new red Ford.
Okay.
You write the main car data to its primary partition based on its ID, but then you need to update the secondary indexes. You have to update the color.red entry.
Which lives in index partition 0.
And you have to update the make Ford entry.
Which also happens to be in index partition 0 in our example, but could be in a different index partition.
Right. So a single document write might now require updating index entries in multiple different index partitions, potentially on different machines.
Ah, that sounds like it could involve distributed transactions or something complex to keep everything consistent.
It could, but distributed transactions are often slow and complex. So many systems using global term partition indexes opt for asynchronous updates instead.
Asynchronous.
Meaning the main data gets written first, and then the index updates happen shortly after, but not necessarily in the same transaction.
So there's a small window where the index might be slightly out of date, eventual consistency.
Exactly. There can be a brief delay. You might write a document and immediately query for it via a secondary index, and it might not show up for, say, a fraction of a second.
Okay. Like Amazon DynamoDB's global secondary indexes, right? They mention that behavior.
Yes, that's a classic example. They typically update very quickly, but under failure conditions or high load, the delay can be longer. It's a trade-off. You accept slight potential inconsistency for better write performance and availability compared to strict distributed transactions.
So term-based gives you faster targeted reads on index terms, but writes are more complex, potentially hit multiple partitions, and often rely on eventual consistency.
That's the core trade-off. Yep. React Search feature uses this, and Oracle data warehouses actually let you choose between local, document-based, and global term-based secondary indexes, which is interesting.
So taking that step back, for the folks listening, especially those prepping for interviews,
it really boils down to understanding this fundamental choice. Do you optimize for simple writes and accept potentially slower scatter-gather reads, document-based?
or do you optimize for fast, targeted reads on specific terms, but accept more complex writes and potential eventual consistency, term-based?
Being able to discuss why you choose one over the other based on expected workload patterns, read-heavy versus write-heavy, latency requirements, consistency needs, that senior-level thinking.
Yeah, it shows you're not just picking a technology, but designing for specific requirements.
And just a quick side note. Sometimes people think, oh, I'll just use a simple key value store and build my own secondary indexes in my application code.
Oh boy, sounds risky.
It usually is. Keeping those application-level indexes perfectly consistent with the main data without database-level transaction support is incredibly hard.
Yeah.
You run into race conditions, partial failures.
Yeah.
It gets messy fast. Generally, rely on the database's features if you can.
Good advice. Stick to the managed solutions. So Ultimately, these secondary indexes, however they're partitioned, are just crucial for getting data out efficiently when you aren't just looking up by primary key.
Absolutely. Relational, document, even key value stores increasingly need them. And for search engines, they're the core mechanism.
Well, hopefully this deep dive has shed some light on the different ways partitioned databases handle this challenge. Understanding these strategies is pretty vital.
Agreed. It's a cornerstone of scalable data architecture.
So maybe a final thought for our listeners to mull over. If you were designing a new system from scratch, how would you actually decide between document-based and term-based partitioning for your secondary indexes?
Yeah, what factors would weigh most heavily? Think about your specific application's read patterns versus its write patterns. What's more important? What can you tolerate?
Exactly. Getting that balance right is key. Thanks for taking the deep dive with us today.